Assalamu alaikum. Myself Maryam Ali. Today I'm going to explain you about timers and counters in the AVR microcontroller chip. Timers and counter modules is a programmable electronic circuit that we can program them or we can use them according to our logic. So basically, why these timers and counters needed if we can program or if we can do these things by using the ports or microcontroller chips. But basically, the thing is that if we are going to use our own made circuits or things, that's going to take much more time to perform things than this timers and counters. Timers are timers are used to create a specific amount of time, like a stopwatch or anything like we have to count. Now the other on the other side, counters are the count pulses used coming from the external sources. But there are timers have of three modules in the 8 mega 328P, and if we talk about the 2560, then there are almost 7 8 timers of different bits like 16, 8, but the maximum thing is that it is of 16 or 8 bit. If we talk about the 328P, then there are three timers TCNT0, TCNT1, TCNT2. TCNT1 is of 16 bit and other of a 2 bit. Now, further on, this is a circuit logic inside the chip here that from the data bus values come here and the counter work and then so on. So this is basically a simple thing like this is an external source or you can say a clock here. This is a counter timer and this counter timer it provides something to this counter register and this counter register when it is full it raises a flag but when it is working inside then it is still zero. Further on, there are five registers, PC and N register. This define the timer register that where the time going to start. Other is a TOVN flag. This flag is the timer flag. That if it is a 8-bit flag, then the maximum number is 255. If the timer goes beyond this or at that point, then it shows the overflow flag and the timer goes to zero then. TCCRN and further OCRN and OCFN. So here you can see that these are the register here. Basically this is the timer here. This is the overflag of it. But if we are using a comparative register then there are two registers A and B. OCRN A and OCRN B. And their overflag register is this one. That we have assigned some value to the OCRN and if we compare this value to timer at that point timer going to show a flag, comparative register flag. Further on, this is TIFRO, which has these TOVO flags here. Further, these are clock selectors here. In the TCRO registers here, the TCRO A register and TCRO B register. In the TCRO A register, there are two WGM. If we talk about now only of clock selector, then it is here in the TCROB. This is a clock sector that we have to know clock source or this is a simple 8, 64 to 56 of or 1024 frequency. And these are the two clocks which going to work. One is on the falling edge and one is on the rising edge. But the thing is that this is the same clock sector in the timer 2, timer 0 and timer 1. But in the timer 2 there is no rising and falling edge seen. Further on, this is a timer mode for 8-bit. which I'm going to show you. This is for 0 and 2 timer it is same, but for the 1 timer it is different. I will show you. This is for the 0 and 2 timer, which is of 8-bit. For the 8-bit, these are 3 selectors here, timer mode selectors, and basically I'm going to show you about the normal mode, CTC mode. When I am on the normal mode, then it is 0, but if I am going to use the CTC, that is the comparative register flags, these ones, then I am going to use them. Further, this is the task 1 here. Display the counting of TCNT register on LCD and also counting how many times the TCNT register is overflowing here. So this is a code here defined. Now get in the code here. The code is that I have assigned some values here, then TCNT is 0. In the while loop, I assign that TCNT 0, so that is mean it is on normal mode. And reflect the clock is selected here. Further on, in the while loop of TIRF flag, this is a flag where TOVO exists. TOVO is the overflow flag. So when these functions perform flag overflow, then it's going to goes here. And similarly, it's going to increment a counter, count 1, and now another while loop. So when these things happens, this count shows a value that is 1 counted and then goes above, then goes down. Again the while loop completed, then it gets the counting flag to 2. This is the, but in hardware, let me show you here. In the hardware, this is the video here. This is going 19, 14, 15, 16, 17, 18. So this is TOVO flag. When the TCNT value increases, the TOVO flag increases, that it is incrementing. Now, the next task is that to make a digital watch using timer on LCD. In this, there are simple things. We are going to perform 3 while loop. Not while loop, we are going to take 3 for loop. And one is for hour, one is for minute, and one is for second. So on the least one is second one. So the second goes to till 60. So the 60 is applied here, equal to 6x. And now it is performing like it is saved in the O array. As I already told you before, this is used when we have to display a value on LCD. So for the M, for the O here is for second, and similarly when this completed, 60 seconds completed, is increment a 1 minute. And similarly again this loop work and increment a 2 minutes, and so on. When this completed, 60 minutes completed, then it increment in the OR. So this is the void delay here. This delay is used here by using timer. So this is a timer here 65499, and it's going to give us a 1 second delay. So here, let me show you. This is the 2, 3, and so on. This I am not going to show you a complete thing, but here when this 60 second goes to 60, then 1 minute is incrementing. This is the code of timer task 2, where we have to perform or we have to clean our second. And now this is the Proteus file here. This is, you can see that 56, 57, this is incrementing, and a minute is incrementing when the 60 seconds is completed. The next task is that count an external event that can be switched on, off, and display on LCD or SAMA segment. When we are going to push the button on or off, our counter is incrementing by clicking this button. So basically, in this code, the simple is that we define a port here, that is 7. 7 pin, we define it, and further as input, we define it in input, and further our TCNT register is defined 00. And now in this loop, it's going to work here. The TCCROA is set 0, and it is in the normal mode, and further TCCROB, that is 0x06, so it is a clock set here. And further on, this is our LCD command 0, that it goes on the line 1 of the LCD, and further it's going to save in the array, and this array. Now let me show you the video of timer task 3.
ये हमारा टाइमर काउंटर का तीसरा टास्क है, जिसमें हम लोगों ने एक्सटर्नल कोई पुश बटन है, उस पर जो इवेंट आएगा उसको काउंट करना है। जितनी दफ़ा वो पुश बटन हम प्रेस करते हैं उतनी दफ़ा ये काउंटर की वैल्यू में इंक्रीमेंट आता है। छोड़ो जरा उसको। अब ये देखें स्टे कर दिए करके वोल्टेज वैल्यू जो है इसकी। अब अगर हम इसको प्रेस करते हैं तो इसकी वैल्यू में इंक्रीमेंट आ रहा है। ये इसका कोड है। कोड पे करो। ये इसका कोड है, जिसमें हम लोगों ने एक पिन डी की 7 बिट को जो है वो कन्फिगर किया आउटपुट, उसके ऊपर हमारा पुश बटन कनेक्ट होगा। बाकी वही हमारी एलसीडी जो हमारे पास है, एलसीडी को इनिशियलाइज करवाया और उसमें स्ट्रिंग वाले फंक्शन कॉल भेजी है, और वही हमारे पास हमने टाइमर जो है वो 0 को तभी है। ये हमारे पास इसकी सिमुलेशन है, और ये हमारी वैल्यू में इंक्रीमेंट आएगा जब जब हम उस पुश बटन को प्रेस करेंगे।
ये फिर ऑनवर्ड हमारे पास काउंटर इंक्रीमेंट। So this is the hardware, this is software. So this is all for today. Thank you.